So section 4.1, Extrema on interval. You will see there's a lot of notes, but when we do examples, it's going to be super easy. So let f be defined on an interval I containing a point C. C with the x coordinate, okay? If f to the c, that means the y coordinate for this point, is the minimum of f on the interval I, if this point, the y coordinate is less than all the y coordinates for the point, for the all points of x. As an example. So here's the interval, A and B, okay? So let's check. If this is the point C, this here is going to be f to the c. Now, f to the c, I'm talking about only this interval. C between the interval A and B, f to the c is called what? Called minimum point. Why? Because it's the minimum point between the interval A and B. You see everything here, all the x value here, f, that means f to the c is less than all the y for x values. Okay? Now let's check the second one. F to the c is maximum of f on the interval I if the y coordinate for this point C is greater than all the y coordinates for other points. For example, this one. Now, if we have, let's say this is C1 and this is C2. So C2 between A and B, this is F to the C2, which is the maximum point here. That means this one is called max. Here is called. So you just have to know the max and minimum. Now, relative extrema. More about this one. I'm just gonna explain the same graph. Okay. Because now this is the maximum point. So what are you gonna call this one? The absolute maximum. Because it's the maximum point on all this interval A and B. Okay. Now let's look here. This is the minimum point. So we're gonna call this one absolute minimum. Now, if you look to this point, it's also a maximum point. Okay, so we're gonna call this one another max point, but we're gonna call it relative. We're gonna call this one relative max. It's also maximum point, but it's not the extrema maximum. So the extrema maximum, we're gonna call absolute maximum. Another maximum, but it's not the extrema one, we're gonna call it relative max. Okay. Now with the same thing with the minimum. If I choose this point as a minimum point, I'm not gonna call the extrema minimum or absolute minimum, because the absolute minimum here. So I'm gonna call this point is relative max, minimum, sorry. Okay. So the extrema, you're gonna call absolute max. Another maximum point, you're gonna call it relative max. This is the extrema minimum. You're gonna call it absolute minimum. Another minimum point, but it's not the extrema one, you're gonna call it the relative minimum. And all these written here, well, the next one is going to be the relative and the maximum. But the main thing, how we're gonna find these, check that when we do an example. So the extrema Wire theorem, we're gonna do the same thing. Now, if f continues on a closed interval AB, then f has both maximum and minimum in the interval. Check here, this example. Now, here's the interval A and B. Closed interval. So check here. This is the maximum one. So we're gonna call this is the absolute. Oh, here's the absolute max. Because I have two maximum, right? Two maximum point. This is the maximum one, the extrema one. So I'm gonna call it absolute max. This is also maximum point, but I'm gonna call it relative max. Now here's two minimum points. This is the relative minimum. This one is called what? Absolute minimum. Because it's include the interval. That's why I have to include it's an absolute max, it's absolute minimum. How to find the extrema? And you have to know. The extrema, to find the extrema, it's work with the first derivative. Because next section, we're gonna use the second derivative. Okay? So first, find the critical numbers. This is the first thing you're going to do. When you need to find the extrema, you're gonna find the critical numbers. How are you gonna find the critical numbers? The derivative equal to the zero. You're just gonna find the derivative and equal to zero. And you have to solve it to find the value of x, which is going to be the value of x. You're gonna plug it in the function to find the y, and you're gonna get the point. The point, which is extrema, maximum extrema, or relative extrema, okay? You're gonna check that. What does that mean? It's a critical numbers. That means numbers make the function equal to the zero or undefined. Okay, so you have to be careful with this one. And I'm gonna ask you a question. Evaluate at each critical numbers and each what? Endpoint, which is this one. So when you need to evaluate, you're just gonna evaluate. That means you're going to find the y value, not only on the critical numbers. You're gonna find the y value at the endpoint, AP. Okay, because here's your interval. If the interval is closed, if it's open, you're not gonna evaluate. Only if it's closed. Why? Because if it's closed, that means these two numbers include the interval. So you have to evaluate. If it's open interval, you don't have to evaluate the endpoints, just the critical numbers. Okay? How are we gonna find the critical numbers here? What they tell you? To find the critical numbers, you have to find the derivative and equal the derivative to zero. So the derivative for this function, you see, it cares about the derivative. And this is easy one. What about if you have cosine, tangent, cotangent? Different. So you have to at least memorize some of these. So to find the derivative here, the prime to the x is going to be 6x to the power 5 minus what?
30x to the power 4.
X to the power 4. Okay. Now I'm gonna take the derivative and equal it to zero. How are we gonna solve this one?
Factor
Factor what?
6x to the third to the fourth.
The 4. 6 and the 4, just common between these two terms. And what's the left? X minus what? 5. So giving 6x to the power 4 equals 0, or x minus 5 equal to 0. From this side, if you solve it, x is going to be what? And from this side, x is going to be equal 5. So these are the critical numbers. That hard? Yes or no? What about this one? Find the critical numbers. Find the derivative. How are you going to find the derivative here? How are you going to find the derivative here?
The x squared to the top.
Yes, you can. You can say, okay, here is y prime equal. The derivative for this part is what? 2. Here, before finding the derivative, what I'm going to do, you can use the quotient rule here. You can use the quotient rule, or I say, okay, I'm gonna make it easier for me, because I know you hate the quotient rule. So 2x plus, you're gonna say here is the same thing, 8x to the negative 2. Gonna be right. And then the derivative is going to be y prime equal 2 minus 16x to the negative 3. Now, can I bring back the x negative 3 to the bottom as a positive exponent? I can say y prime equal 2 minus 16 over x cubed. Both is going to be right. If you're using the quotient rule, going to be the same result here. Now I'm going to take the derivative and equal it to the 0. Now, how are we going to solve this one? We're going to solve this one. Don't overthink it. What is the problem?
The
The problem is
x cubed on.
on the bottom. How are you going to cancel this one?
Move it to the top.
How?
The negative, make it negative.
No, because it's going to be still a problem. Because it's negative.
On both sides by x cubed.
Multiply both sides by x cubed.
Oh,
So I'm going to multiply everything here by x cubed. That to me is going to be 2x cubed minus 16 over x cubed times x cubed equals 0 times x cubed is going to be 0. Cancel these. So give me 2x cubed minus 16 equal 0. That's me. 2x cubed is going to be equal 16. So x cubed, 16 divided by 2, which is 8. That means x is going to be equal to, well, it's cubical for both sides. So x is going to be 2. Now, how many critical numbers do we have? And be careful here. You're gonna plug in, you're not gonna look to the function. You're gonna look to the derivative. Which one is gonna make the derivative undefined, which is also the 0. So 16 divided by 0 is going to be undefined. That means the 0 is a critical number also. Not the original function, the derivative. Okay? And now how are we gonna find the critical numbers for this example? You can move the x cubed to the top and work as a product rule, so you can keep it and work as a. So that means f prime to the x is going to be equal. The top, how are we gonna start? The quotient rule.
It starts with the denominator.
Okay, so x cubed
Cube,
times the derivative here. How are we gonna do the derivative here?
it's the chain rule. So it's gonna be
Well, we're using chain rule. Okay, so you can use the product rule, it's fine, but it's gonna be hard. But before that, can I just distribute the 9? Because it's a number by itself. So I'm gonna say, okay, this one is equal 9x squared minus 27 divided by x cubed. If you're using the product rule between 9 and the parentheses, it's going to be right. But it's going to be a product rule here, and you have to go back to find the derivative on the bottom part. So it's going to be really long steps. So now I'm going to work on this one. I'm going to say the bottom part times the derivative here, which is
18x.
18x. That's it. Minus the top part, which is 9x squared minus 27 times the derivative here, which is 3x squared, and everything divided by x cubed squared. Now what's the next step? Prime to the x, here is going to be 18 x to the power 4 minus 9x squared. But I'm going to distribute this one here. So 3 times 9
27,
Okay,
x to the fourth.
so 27 x to the power 4 minus what? So plus 3 times 27.
81 x squared.
81 x squared. So we can divide by x to the power,
3,
no,
3 and then, oh, okay. Oh, okay.
because x cubed squared, you multiply the exponents. Now, 18 minus 27. No, 6. What was the next?
Negative 9 x to the fourth,
Negative 9 x to the 4,
plus 81.
81 x to the 4. Tell me what's the next? Okay, now here is the derivative. I need to find the critical numbers, so I'm going to take the derivative unequal to the 0. So here is the derivative. Over x to the power 6 and equal to 0. Now tell me, can we simplify it before we go into the next step? How?
Factor the top.
Factor what?
9 squared.
Okay. 9x squared. What's the left? Going to be x squared
Negative x.
negative x squared plus 9 over here is equal to 0 over x to the 6. What's the next?
Multiply by x to the 6.
Before that,
Since x to the 6 on the bottom, that'd be like this over here where x is gonna be 0.
before that. Don't overthink also.
Okay.
The derivative here, okay, it's right. That the 0 it's a critical number.
Yeah.
Let's look here. How are we gonna
Can you cancel the 2 with 2 on the bottom?
So
So the x.
That's
to the
mean
fourth.
x squared because it's multiplication. So I can cancel 2 from here and 2 from here is going to be 4. That's mean 9 negative x squared plus 9 over x to the power 4 equal 0. Now what's the next?
Multiply by x to the fourth.
Multiply by x to the 4. That's mean going to be 9. We're going to multiply by x to the power 4. Cancel here, so it's going to be 9 negative x squared plus 9 equal to 0. What's the next? What's the next?
Distribute the 9.
Oh,
Divide by 9.
'cause-
Oh, you're solving for x.
so you're gonna say 9 equals 0 or negative x squared plus 9 equals 0. Yes or no? Now, is that x squared is going to be equal 9? Take the square root, that means x is going to be equal plus or minus 3. So is this statement right? It's the wrong statement. We can say 9 equals 0. 9x equals 0 is different. But now a number equals 0, which is wrong. So this is a wrong statement. So now how many critical numbers do we have? No?
3.
Where's the third one?
X is 0.
The 0.
Did you have divide?
But we need to find what? The absolute extrema for the function on this intervals. So the first thing, we're gonna find the critical numbers. That's mean f of prime to the x is going to be equal.
6, right?
Take the derivative equal to the 0. So 6 x minus 12 equals 0.
X equals 2.
6x equals 12. Then x is going to be equal to 2. Divide both sides by 12. So by 6, we need x equal. So I have, here is the critical numbers.
You plug that in into the.
Yes,
function.
but you have to plug in the critical number and the endpoints. The endpoints for the interval.
Oh.
So you're gonna create table. That's what I'm doing. I'm gonna put x, and here is f of x. The critical numbers
So it's X and Y.
0, 2. Here is the 2, 0, and we're gonna put the. This is the x. Okay, now I'm gonna plug in. If I plug in 0 here, 0 and 0, so we're gonna get 3 times 0 minus 0 is going to be.
Zero.
That means the third point is 0. Okay, on the graph. To check if you graph it, you can tell which one is the maximum, which one is the minimum. And be careful. When you say 0, 0, it doesn't mean it's going to be minimum.
Could be negative.
Could be the other point, it's less than this one. Because I'm going to look only for the y. And you can tell which one is the maximum, which one is the minimum. Now plug in the 2 here. So it's going to be 3 times 2 squared minus 12 times 2 equal what?
Negative 12.
Here's a 12
Yeah.
minus 12 minus 24.
Yeah.
It's going to be negative 12. That's mean negative 12. So the other point is 2 and negative 12. Look to the y.
Mm.
Which one now with these 2 points? Which one is the max? Which one is the minimum?
Zero's maximum and negative 12.
This one's the minimum. But I can't tell it's absolute max or absolute minimum until I find the third point. So the third point, you're gonna plug in 3. That means going to be 3 times 3 squared minus 12 times 3. It's going to be equal what? This is 9, 27,
Negative 1.
negative 9. So it's going to be 3 and negative 9. Look to the y. So now we can tell. This is,
Maximum.
which is the absolute max. Now these 2 points are minimum. But this is
Absolute.
absolute minimum.
How do you know which one becomes the relative maximum or relative?
Oh, okay. So go ahead and grab the points. That's good. Waiting for this one.
I meant to ask you that while you were up here.
Okay. So let's grab the first point. It's 0, 0, right? So here is the 0, 0. The second point is 2, 12. So let's say here is 1, 2. Let's say here's 2, 12. 5, 10, 2, 12 here. Okay? 3, negative 9. So it's going to be here. Here is the 3, and here is
9.
Negative 9. So when you graph, because we need to find the graph only between 3 and 0. Okay? Now you can tell this one is the absolute max, is the maximum point on this graph. And this one is the absolute minimum because it's the minimum point between 0 and 3. So this one is considered what? Relative minimum.
But how? Like, how is that not like a relative max?
No, because it's near the minimum.
At what point does it?
Like you can say
become
until the half.
half?
Yeah, but you can tell this
Or like
one,
negative
you can
6.
consider relative minimum. It's not the absolute minimum, it's a relative minimum, okay? Not max. If it's a point here, what are you gonna say? You're gonna say relative minimum,
Relative maximum.
you're gonna say relative maximum.
So what if it is in the middle? What if it's
You're not gonna get this point in the middle.
okay.
So now we're gonna do the same thing. To find the absolute extrema, I'm gonna say here is the derivative equal what? -1. Then I need to find the derivative equal the derivative to 0. So like, can I say -1 equals 0? So what I'm gonna do,
Your, endpoints, so that's all we got.
that's the only thing we have. We don't have a critical numbers, so I'm gonna check the endpoints. So I'm gonna say, okay. X, and here is alphabet X. And the first endpoint is -3, and the second one is 5. So plug in -3 here, and be careful. Be careful sometimes if you say, oh, it's easy, you're gonna do mistakes here. That's what happened last semester. -3 minus, it's a 3. Minus what?
It's gonna be 6.
Minus -3. So that result is going to be 6. So the point is -3 and 6. And you're gonna plug in 5. So it's gonna be 3 minus 5, which is equal -2. So the second point is 5, -2. So now you can tell. Always look to the y. This is absolute max on this one. Absolute max. This one absolute. Yeah. That's so we're gonna do the same thing.
Be product rule.
Find no why.
You can't do negative
7.
9. -7 over
Yes.
sign.
So f of y is going to be -7 sine x. That's it.
We just keep the 7.
Yeah, because if you do the product rule,
Oh, yeah. It's
The
gonna
same
be
thing.
0. Okay.
same thing. You can do the product rule. You can say, okay,
Yes,
the
okay.
first one times the derivative here, which is negative sine x, plus the second one times the derivative of 7 is, so everything here is zero.
Slower.
No, it's fine. You can do that. I used to be doing this. -7 sine x. So then I wanna save time. Then how we gonna find the critical numbers? You can say -7x, 7 sine x equals to 0. What's the next step?
-7. Oh, wait, no.
You can do that, it's fine. You can say divide by -7, or you can say, okay, -7. Okay, let's divide by 7.
Oh, -7 equals 0.
Yeah, it's
And
negative.
x equals
So
0.
if you divide by -7. Divide by -7, divide by -7. It's still here, sine x equals. Fine if you do that. Now, sine x equals 0. Okay? When?
This is when you leave the pie chart, the chart,
And then
Okay,
the circle.
equals
the
0.
second one. But when, which number I'm gonna plug in here? So sine to this angle is going to be equal to 0.
90 degrees.
90 is not gonna be.
No.
It's between 0 and 2 pi.
Oh.
Sine
Pi.
pi, so that means x equal pi. What's the next number? If you put pi here, sine pi is going to be 0. What else?
Negative pi? Is that, no?
Because negative pi is out
Oh, yeah.
the interval.
I guess pi. Where's my unit circle? I know for sure it's 90, and then it's also
Don't
What?
look down, because from 0 to 2 pi. So we look
well,
on
2
only-
pi. 2 pi is 360,
So we look on
so it's gonna
only.
be 270, which is
Okay, so. we
3
look on-
pi over 4,
God, do you memorize that?
right?
No,
Oh, what is it? 7 pi? No,
No.
it's wait. 1,
Wow.
2, 3,
so, oh, wait.
4,
Okay.
5.
Can I Google the unit circle?
Sure, it's
Don't
it's
go.
9. Oh, so it's okay. 9 pi out
So,
of 12.
okay, it's 0. At 0, right? Come on. And here is pi, here is what? Here is pi over 2, here is
2 pi?
Here is 0 pi, and this is 2 pi, right?
Uh-huh.
So I have 0 and I have 2 pi. Sine 0. Sine 0 is what?
And 0 is pi over 2.
No, sine 0 is 0.
Uh,
And, and sine pi is 0. And sine 2 pi is what? Is also 0.
0.
So that means I can choose only pi. Because I have 0 and I have 2 pi. You didn't get it?
No.
So here's the thing. We need to find what? The critical numbers, right?
That's including 0 and 2 pi.
And 2 pi. You can include the 0 and 2 pi.
But that's the same thing.
Because it's the same thing exists there.
Yeah. Okay. I see what you're saying.
So at this point, and you can keep going. Pi, 2 pi, 3 pi, 4 pi, and whatever. Because all these sine to the 3 pi and pi is going to be 0. Because you're going to keep going circles. But I need to go between these two intervals. That means the critical number, the actual critical number is only the pi. But the end point is what?
0 and 2 pi.
0 and 2 pi, okay? Because these are an interval, okay? So now,
What's next?
x, alphabet x, so I'm gonna put here, 0, pi, 2 pi. Now with 0, you're gonna plug in here. Now, you see, this is the cool thing. Now I'm gonna plug in 0 here. 7 cosine 0 as well. What? 7, because cosine 0 is 1. 7 times 1 is going to be 7. So the point is going to be 0 and 7. Now go ahead, plug in the pi. 7 cosine pi equal what? But cosine pi is what? -7, -1. So 7 times -1 is going to be -7. So it's going to be pi and -7. What about this one? 7 cosine 2 pi equal what?
Can be also 0, 7.
It's going to be also 7. So it's going to be 2 pi and 7. So this is absolute minimum. What about these two?
Those are gonna be. Those are gonna be. Those are gonna be.
Absolute maximum.
So for sure, this is absolute minimum.
Mhm.
So he said absolute maximum. Which one?
0, 7.
Because this is the same height with this one. With the cosine and the sine, you get the same wave.
So they're both the
Yeah.
same thing.
Yeah. So can I say this is absolute maximum? What about this one?
Same thing.
I have 2 maximum.
Relative.
So both is going to be. This is the answer for your questions. So this is relative.
So they're both relative.
Both relative because there is no extrema maximum.
Oh,
They are the same height. So when you graph it, with the wave is going to be the same height like this, and go back again. You see? So if it's the same height, you can't. In fact, it's going to be goes down. So when you graph it like this, and keep going up. So at this point, the same height. So both are what?
Relative.
Relative, because there's if this is higher than this one, you're gonna say maximum, the absolute maximum. So both this point is going to be relative max. Okay.
He was hardcore.
Find the extreme. So we're gonna find the derivative. X prime to the x is going to be equal. bottom part times the derivative on top, which is 1, minus the top times the derivative of the bottom, which is 1, over. Simplify it. So it's gonna be x plus 3 minus x divided by. Yes or no? Cancel the x with the x. So what's the left? 3 over x plus 3 squared. This is the derivative. Now we're gonna take the derivative and equal it to 0. So 3 over x plus 3 squared equals 0. What's the next step?
We'll multiply by the denominator, then it's gonna be 3 equals.
Okay,
It's
so-
not equal to.
So you're gonna multiply by x plus 3 squared. Multiply everything here, the left on this side is 3. Multiply this one by 0, it's going to be 0, which is the wrong statement. So there's no critical numbers. 3 equals 0. So what I have to do? Just check the interval we have. X and f of x. Plug in -1 and plug in 6. So if you plug in -1 here, it's going to be -1, -1 plus 3, 2. So it's going to be -1 over 2. So here is -1 and -half. Plug in 6, 6 over 6 plus 3, which is 6 over 9. 6 over 9, which is 2 over 3. So 2 over 3. So the second point is 6 and 2 over 3. So you can tell this is positive, this is negative. So this is the absolute minimum. And here is going to be absolute. It's okay. So far. Let's do the other one. 2 more questions will be in. What about this one? We need to find the extrema on this interval. So h prime to the x equal. Go ahead, who's gonna tell me the derivative? Leave this one here. I'm gonna leave it. Who's gonna tell me the derivative here?
It will be cosine squared.
2 cosine.
2 sine, it's the quotient. The quotient, sorry, not the quotient, the chain rule.
Okay.
So it's 2 sine x, then the derivative for the sine is
It's gonna be
cosine x, then the derivative of the angle is
1.
1. The derivative of the cosine now here is
Sine.
negative sine x. Okay? That's the full part. So what's the common here?
Sine.
Take the sign out. Sine x, what's the left? 2 cosine x minus
You factored out the sine.
The sine.
See.
So now I need to take the derivative equal to 0. That's in sine x. 2 cosine x minus 1 equals 0. And what's the next?
Sine x equals 0.
Okay. Because this is multiplication. Let's say sine x equals 0 or 2 cosine x minus 1 equals 0. Now let's solve this one. So 2 cosine x equal 1. That's mean cosine x equal half. And this is already solved. Now let's look to the x. From here, how much is going to be x? And from here, how much is going to be x? Now tell me, which function, which angle you're gonna plug in here to get sine x equals 0? But be careful between 0 and 2 pi. So we have 0, we have 2 pi, okay? I'm not gonna write down these because these are the endpoint. Where's the other angle?
Sine x for 0,
Five.
pi.
Pi. I'm gonna say, okay, here's pi. Now, from here. Which angle?
For half,
Well, half. Which angle give you? Two angles give you half.
so it's gonna be 60 degrees,
60 degree, that's mean,
120.
120, okay. Tell
Yes.
me in radian mode.
That's 60 degrees, so 60 degree, 120, so it's gonna be.
So 60 pi divided by what?
Pi divided by.
Pi divide 4 is going to be 45. Pi is 180.
By 2? No, wait.
No, pi, the angle pi is 180.
Five over
Huh?
six.
Pi over 6 is going to be 30.
Oh.
So pi over 3.
Pi over 3. Okay, so pi over 3. What's the next one? 120.
So pi over.
Not pi.
2 pi over 3.
No, because 2 pi is going to be 360. You need to get 120.
It's one.
So okay, so it's 3 and here's pi. But which number you're gonna multiply by pi and divide by 3 to get 120? No.
4 pi?
Okay, go ahead. 4 times 180.
Yeah.
Divide by 3 is going to be 120. Yes, you can
Yeah.
try. No,
No.
7 pi.
no, that's too
No,
much.
too high.
So pi over 60, pi over 3 is right, but you have to put number here.
2. 2 pi over 3.
No,
It's 2. 2 times 180
360.
divided by 3 is 120.
No, so it's not 120.
It's not?
Multiply 5. 5 times pi.
5 times. Okay, divided by 3. It's 300.
300, which is 360 minus.
Oh, because it's on the. Okay, I see. Yeah.
So pi.
Oh, I hate this class.
You have to finish it.
I know.
So now how many points you have to evaluate? You have 3 critical numbers, but we need to find the maximum and the minimum. We have this critical, and here's 2 criticals, 3, and we have these two. So you have to create a table and plug in all these numbers. Got it? I know you hate radical.
Yeah.
I know. Here's T. You're just gonna say it's half. Right? Now what's the next step? Find the derivative. The derivative of T is going to equal the first one times, I'm going to the product code. The derivative here is going to be half 4 minus T to the negative half times the derivative of inside is negative 1. See how it's called? Plus the second one
4 minus t, 2.5 hours.
times the derivative of the first one is 1. Now let's just simplify it. Can I write down this as a negative t over square root 4 minus t? Yes? What do you think? Plus square root of 4 minus t.
Multiply the negative one with the zero. That's why it's negative.
Oh, yeah, that makes.
Oh, with this one, yeah.
Yeah, okay.
The beginning. And what's the next? I'm gonna take everything and equal it.
Zero.
The zero. Oh, minus t. What's the next step? There's the zero. I love zero. Not on the test. The zero make everything easier.
Oh, I thought you meant like that on the test as your grade.
Yeah,
Oh,
you want a zero on the test
no,
with 10?
maybe with a 1 and 2 zeros behind it.
Wow. Okay. Now what's the next step? Come on, we need to finish. Now 3 minutes. Don't make it hard. What are we gonna do?
Subtract,
No,
no,
We get like. These common denominators?
yes.
Yeah, so square root of.
Put this one over
4,
one. Just when you do this step, when you put this term over one, you're gonna figure out, okay, I'm gonna multiply both sides by this by the root. So you're gonna multiply by this one by square root 4 minus t, and here you're gonna multiply by 4 minus t,
It's gonna be.
negative t over,
It's to be
and here is going to be
square root of 4 minus t. This is gonna be 4 over square root of 4 minus t.
okay equals
Right?
now
negative,
negative t plus 4 minus t.
Oh, no.
2t,
Plus 4 minus t over the root 4 minus t equals 0. That's mean going to be negative 2t minus 4 over square root of 4 minus t equal 0. What's the next step?
why is it minus 4?
Oh, it's a plus. What's the next step?
Multiply both sides by square root of 4
I don't know where I get the answer here. Oh yeah, we have something wrong.
Really?
Yeah, we have. I felt it. Where is the wrong? Where is this stupid two?
Oh,
You did that too quickly. I was like, wait, what? No, everybody agreed with you.
Don't agree always with me.
I was trying to combat it, but.
So here's 2. So I'm gonna multiply everything here by 2. I need to get the same denominator. That means here is going to be 2. And here is going to be 2 with 4 minus t. See, it's make a huge difference because we have 2 here. So now when you distribute this 2, it's going to be 8 minus 2t. That means 8 here plus 8 minus 2t. Here's 2. Now combine these. So it's going to be 3t here.
-3.
Here's 8. Now what's the next step?
Now multiply
Everything by the square root.
by 4 minus t.
So what's the left here?
You're gonna be left with -3t plus 8 equals 0.
Equals 0. That's mean negative 3t equal negative 8. T is going to be what?
8 over 3.
That's the critical number.